Hello there, this is an Algebra 2 video. It is Chapter 5, Section 6, and it is the remainder and factor theorem that we will be discussing today. So before we get started, I want to do this example to see if we can compare our answers here. So this is just going to show you kind of where this remainder theorem is coming from. So we already know from previous lessons how to divide by x minus 3. I'm going to go ahead and use synthetic division. So because I'm dividing by x minus 3, I'm going to put a positive 3 out here. My coefficients of my polynomial will be negative 3, positive 5, and 4. Bring down the negative 3, so I get negative 9. 5 minus 9 is negative 4. And 3 times negative 4 is negative 12. And negative 12 plus 4 is negative 8. So this is what we know as the remainder. Our answer would be negative 3x minus 4 minus 8 divided by x minus 3. In other words, negative 8 is our remainder. Well, I want to leave that there for a moment. And it says now compare the remainder to f of 3. I don't know if you are aware or if it's hitting you right now that f of 3 just basically means evaluate the function when x is 3. So that means that I take my function f of x and I'm going to go negative 3 and I'm going to replace all the x's with a 3 and evaluate. So this is going to be negative 3 times 3 squared, which is 9. 5 times 3, which is 15, plus 4, so this is going to be 19. And negative 3 times 9 is negative 27. And negative 27 plus 19 is, lo and behold, negative 8. So it's not a coincidence that when I evaluated the function at 3, I got negative 8, and the remainder was negative 8 as well. So basically it means that f of 3, which is equal to negative 8, is the same as the remainder was in the previous example up here. So basically what we have in the remainder theorem is that the remainder after you do synthetic division is the same as evaluating the function of f of 3. And here we have the actual remainder theorem written out. And it's p of x equals q of x times x minus r plus p of r. In other words, the dividend, this is the part that goes underneath the division bar, is equivalent. So this is basically the original problem. So here's my example. The original problem was the dividend. And the quotient is the answer, which we got earlier as negative 3x minus 4. Times x minus r, this is what we divided by. In our case, we divided by x minus 3, so there's that, plus the remainder. It's kind of like when you say, it's the same thing as saying, if I took 15 and divided that by, I don't know, 2, 2 would go into 15 7 times. 7 times 2 is 14. You subtract, you have a remainder of 1. So basically it means that 15 is equivalent to 7 times 2 plus 1, which is true because it would be 14 plus 1, which is 15. So you have your dividend, what goes underneath the house, the answer, which is 7, times what you're dividing by, which is 2 in this case, and you add the remainder. So that's basically what the remainder theorem is saying. And furthermore, that we can use synthetic division to find p of r. So p of r is the remainder, but p of r is also the function evaluated at r. Okay, notice that this is x minus r, but the r in here is positive. So when we're dividing by x minus 3, we plug in a positive 3. So it says here in example 1, if f of x equals 3x to the 4th minus 2x cubed plus 5x plus 2, find f of 4. So obviously one option would be to plug 4 into all of the x values. But believe it or not, you can start getting some really big numbers that way. So it's actually a lot more convenient for us to use synthetic division. So we're going to put a 4 out here, and then 3x to the 4th, negative 2x cubed. There's no x squared term. So 4, 3, 2, 1, and then none. So 4, 3, 2, 1, none are our terms. And then we can go 3 times 4 is 12, 12 minus 2 is 10, 10 times 4 is 40, 40 plus 0 is 40, 40 times 4 is 160, is 165, 165 times 4. I have no idea what 165 times 4 is, but I'm sure it's a big number. 660, and then you get 662. So our remainder for this example is 662. So now I would like for you to try A and B, and again, rather than plug 3 into the function, I'd actually like you to use synthetic division to evaluate f of 3 and f of -1 for the do-it-yourself question. All right, so then we have example 2. And in example 2, we're going to be applying this whole idea with a word problem. It says the number of college students from the United States who study abroad can be modeled by the function s of x equals 0.02x to the fourth minus 0.52x cubed plus 4.03x squared plus 0.09x plus 77.54. Where they got that formula, I have no idea, but there it is. Where x is the number of years since 1993, and s of x is the number of students in thousands. And it's asking how many U.S. college students will study abroad in 2018. So what we need to figure out is how many years since 1993 is 2018. So 2018 minus 1993 gives you 25. So that means that x is going to be 25. So what they want to know is what is s of 25? What is the value of the function when x is 25, which will tell you how many college students will study abroad. So rather than plug 25 into the function, we're going to use synthetic division with a 25 out here, and then we want our coefficients. So we're going to go 0.02x to the fourth, negative 0.52x cubed, 4.03x squared, 0.09x, and 77.54. So we have 4, 3, 2, 1 nut. Everything looks good there. 0.02 down here gets carried. So we're going to go 25 times 0.02 is going to be 0.5. And 0.5 minus 0.52 is negative 0.02. And negative 0.02 times 25 is negative 0.5. And negative 0.5 plus 4.03 is 3.53. And 3.53 times 25 is 88.25. And 88.25 plus 0.09 is going to give us 88.34. And 88.34 times 25 is going to give us 2208.5. And that plus 77.54 will give us finally 2286.04. And this here be our remainder. Now remember that I said that s of x was in thousands. So that means that we have, if we take that and times it by 1,000, we basically get 2,286,040 students from the U.S. that are studying abroad. Awesome. So now you can try this do-it-yourself question. And then we have one mass theorem. The section was called the remainder and factor theorems. Now the factor theorem I kind of already alluded to in a previous lesson, so maybe you were picking up on that and in class. Basically, we know already that the evaluating the function, that P of R over here, is the remainder. And so what we're talking about here specifically is what happens when that remainder is 0. I always like the example, for example, earlier we were dividing 15 by 2. We know that 2 is not a factor of 15. In other words, there's no number times 2 that will equal 15, no integer anyway, that will multiply by 2 to get 15. Hence why you get a decimal when you divide, and a remainder. We know that 3 and 5 are factors of 15 because 3 times 5 multiplied to get 15. But also because when you divide 15 by 3, it goes in evenly. In other words, when you say that something goes in evenly, it means that there's no remainder. The remainder is 0. So the factor theorem here is all about the remainder theorem being 0. It says the binomial x minus r, so what you divide by, this x minus r thing, is a factor of the polynomial p of x if and only if, and there's that double F from geometry that you guys saw last year, if and only if p of r is equal to 0. So if and only if the remainder is 0. So if you have a 0 remainder, it literally means that you are a factor of the polynomial. So it says here in example 3, determine whether or not x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15. And if it is, then find the remaining factors of the polynomial. So we're going to use synthetic division. It doesn't matter what type of division you do, as long as you divide. So we're going to take, and because it's an x minus 5, we're going to put a positive 5 down here. And I'm going to try to find the remainder. If I get a 0 remainder, then it means that x minus 5 is a factor. If I don't get a 0 remainder, then it's not a factor. So we're going to get 1x cubed minus 7x squared plus 7x and then plus 15. So we have 3, 2, 1, none. We bring our 1 down. 1 times 5 is 5. 5 minus 7 is negative 2. 5 times negative 2 is negative 10. Negative 10 plus 7 is negative 3. 5 times negative 3 is negative 15. And 15 minus 15 is 0. And lo and behold, we do in fact get a 0 remainder. Because this is a 0 remainder, it means that the x minus 5 went in evenly to x cubed minus 7x squared plus 7x plus 15. Now using the remainder theorem, which we talked about earlier, it means that the polynomial, the original polynomial, which is what we call the dividend, if you remember earlier, the dividend, which is the original polynomial, is equivalent to the quotient, the answer, which is right here. We got x squared minus 2x minus 3 multiplied by the divisor, which was x minus 5, and then you add the remainder. And that is, in case you don't remember, this guy right here. Dividend equals the quotient, the answer, times the divisor plus the remainder. But in our case, the remainder is 0, so we're not really adding anything here. So basically, if I multiply these two together, I will get that. So this is important to know because it says find the remaining factors of the polynomial. We already knew that x minus 5 was a factor because that's what the division told us. But now it wants us to find the remaining factors. So now we have this quadratic, and we can actually factor that to get the other two factors. We don't have to keep dividing. We can now use our factoring techniques. So we're going to say 3 times 1, and we're going to go negative 3 and a positive 1 here so that we can get negative 3 on that diagonal, plus a positive 1 on that diagonal, which will give us a negative 2, which is in fact the middle term. So the other two factors are going to be x minus 3 and x plus 1, along with the x minus 5. So now we have all three factors together. And that is how you use the factor theorem to help you factor the polynomials. So now we'll have you do this example where it wants you to show that x minus 2 is a factor by doing the division and determining that they have a 0 remainder, and then using the remaining quotient to find the other two factors of the polynomial. So once you have done that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.